In this video, we're going to take a little bit more time to understand some of these different numeric types. Now, we could understand these types by creating maybe a new table inside of a Postgres database, adding in a couple columns to it, and for every column, we could annotate it as a different data type. We could then insert some rows of data into that table and just observe how Postgres treats all these different types of numbers. But creating a table like that would take a little bit of time. So I'm going to show you a little trick that we can use to play around with these different data types in Postgres without having to create a whole table with a bunch of columns inside of it. So here's what we're going to do. Back over inside of pgadmin, I'm going to find the databases section right here. And remember, you might only have one database depending upon your environment, specifically if you're on Windows or Linux. Even if you have one, doesn't matter for what we're doing right now. We're going to right-click on Postgres right here, and then click on Query Tool. This is going to open up a little editor. We can write in some SQL right here, and then immediately execute it by clicking the play button on the right-hand side up at the very top. Now, at this point in the course, we've seen a lot of SQL where we select rows of data from a table. But it turns out that we can also do arbitrary numeric calculations with SQL as well. Let me show you how. We could write out something like select 2 plus 2, semicolon. I'll then click play, and we'll see the result of that calculation appear right here. So we're going to be writing out a couple of different statements that look just like this to really understand how Postgres treats different numbers. In particular, we're going to use a little operator that's going to tell Postgres that we want it to treat a number in a very specific way. Let me show you what I mean. If I put in just select 2 with parentheses around it, and then click play again, you'll notice that I get a result right here, and the column is marked as type integer. So clearly Postgres has figured out or made the assumption that this is supposed to be an integer number. If we put in 2.0 and click play again, now Postgres thinks that this is a different type of number. It thinks it's a numeric value. We can force Postgres to treat this number in a different way, or essentially try to get Postgres to convert this number to a different data type by putting in : and then the type of number that we want Postgres to treat this as. So we can get Postgres to treat what looks like a number with a decimal as an integer by putting in : integer, like so. I'll then click on play again, and now you'll see that Postgres says, okay, I believe you, you say it's an integer, I'm going to treat it as though it's an integer. And so you'll notice that the decimal place has fallen off, and we have just 2 by itself. So we're going to use this little trick right here to write in some different numbers. We're going to take that number and tell Postgres to treat it as a different type of number and see what the ultimate result is down here. Now we kind of already did that for integer, but let's take a look at some of these other types as well. How about small int? Let's write out a number, tell Postgres to treat it as a small int, and see exactly what happens. So I'm going to put in, instead of integer right here, small int, and click play. Well, once again, you'll notice that the type has changed to small int. We've lost the decimal point on there, and it's just simply 2. The range of a small int value can only ever range from -32,000 up to +32,000. If we ever try to create a value and assign it a type of small int outside of that range of values, we're going to end up with an error. So, for example, if we put in 99999, that's definitely outside the range of a small int, and play that, we get an error like this right here. We can get the same thing from an integer as well. If we try to create an integer or store one inside of a table that's outside of this range of values, we're going to end up with an error. So for example, if I put in 99999, like so, and then tell Postgres to treat this as an integer, we'll end up with a similar error. So integers in general, pretty straightforward. They're going to be numbers without any decimal points. If we give Postgres a value that is a number and it has a decimal point, the decimal is going to be just silently removed. And integers have a very specific range of values. If we ever give Postgres a number that's outside that range and tell it to treat it as a small int, integer, or big int, we're going to end up with the error message you just saw. All right, so next up, serial values. Now we've already kind of taken a look at these. We only make use of these in general unless you've got some kind of special use case when we're defining an ID column, and we're just going to kind of leave it there for right now. What's a little bit more interesting, and what I really want to spend some time on, are these decimal types over here. So in general, we've got two different categories of types for handling numbers that have a decimal. So the first category is decimal and numeric. The second category are these other three: real, double precision, and float. The big difference between these two categories of numbers is how precise or accurate we want the number to be. Let me give you a quick example and help you really understand what this whole preciseness or inaccuracy is all about. We're going to create two numbers. We're going to annotate them as real, and then we're going to try to do some kind of calculation with them. We're going to see what happens. Okay, so I'm going to come back over here. I'm going to say that I want to create a value of, how about 1.99999, and I'll put in colon decimal. So that's, or excuse me, let's do real to start off with. We're going to put in real. I'm going to subtract from that 1.999998. And I'll also mark that as real. Let's see, did I get those number of decimals correct? Oh, looks like I'm missing one. So the result here should be something like 0.00001. That should be the difference between these two values, right? Well, if we go ahead and play this, you'll notice that we get a kind of weird result right here. That's kind of not what I expected. And you'll notice it is 1 times 10 to the negative fifth. So it is technically 0.00001, but you'll notice that there's also this kind of really big decimal component on there. So the result, as far as Postgres is concerned, of 1.9999 minus 1.99998 is equal to 0.00001 001358. That is what Postgres is saying about this. So why is that? Well, in the world of Postgres, the types real, double precision, and float are treated with floating point math. If you're not familiar with floating point calculations, they are notorious for being somewhat inaccurate when we start making use of decimal values, like what you see right here. In particular, when you start doing subtraction or any kind of arithmetic operation on them, the decimal values are going to sometimes be just totally inaccurate, and you're going to get these extra decimal values placed inside of here. So whenever we are trying to do or trying to store some values related to a value that we don't really care about too much, like for example, the number of liters of water in a lake or the number of kilograms of trash in a landfill, we can make use of these different types over here. Why would we use these at all, however, if they're not precise? Well, the reason is that they're a lot more efficient for running calculations on. We can do math or do calculations with numbers that are of this type much more quickly than numbers of type decimal or numeric. It's only when we have a value that we want to be very, very precise that we're going to reach for the types decimal or numeric. Now, speaking of decimal and numeric, these are essentially the exact same type. You can think of these as being totally identical. Let's try doing the same calculation, but instead of marking these as type real, I'm going to change it to type decimal. If we now play that, you'll see that we get the exactly correct result right here. Same thing if we make use of numeric. Still get the exactly correct result. So our rule of thumb here is that whenever we are trying to store numbers that must be 100% accurate, like the number of grams of gold that someone owns, or their bank account currency, or how much money they have inside their bank account, even though there's a performance hit to making use of a types decimal or numeric, we want to use decimal or numeric. If we're ever trying to store some kind of number that's going to have a decimal tied to it, and we don't really need to be 100% precise, that's when we will reach for these other types of real, double precision, and float. So those are our rules of thumb. Okay, so hopefully this was not too painful. I know this number stuff is a little bit boring, but again, you got to understand it. Now that we understand a little bit more behind these numbers, quick pause right here. We're going to move on to our next data type in just a moment.